Let's look at an example of the derivatives of an inverse function. Now, this is, in my opinion, not the type of question that you would be likely to get in a sit-down exam. Maybe just for practice, it's a take-home assignment because of the amount of work and time that would go into solving it. But in a later video, we're going to look at forming a method of more quickly solving this type of equation, which is we're going to form the Jacobian. We're going to see what it is about when we get to that video, and then we will redo the same example using the Jacobian. Alright, so here now we have a case where z is a function of x and y. So it is a implicit function. Let u be equal to e to the x cos y, and let v be equal to e to the negative x sin y. Right? And by the way, I get this example from the Engineering Mathematics by K.A. Stroud. Right? Now, we want to find the partial derivative of x with respect to u, not y, u. Let me rewrite that. Alright? We want to find the partial derivative of x with respect to v, so delta x by delta v. The partial of y with respect to u, delta y by delta u. The partial of y with respect to v, delta y by delta v. Okay, good. Now, here, if we look again at this general formula, a small change in u is the partial derivative of u with respect to x times small change in x plus the partial derivative of u with respect to y times a small change in y. That's one case. The other one is that a small change in v, well, u and v kind of look alike. So guess what? I'm going to write v in a different color. Alright? So partial of v, the partial of v, or the small change in v, is the partial of u with respect to the, I mean not v, partial derivative of v with respect to x times a small change in x plus the partial derivative of v with respect to y times a small change in y. Alright, good. So we have that. Now, here we can find partial of u with respect to x and the partial of u with respect to y. So here, from this, partial derivative of u with respect to x is equal to, what do you think it is? Well, when you differentiate e to the x, is e to the x that you get back, and the cos y here, you treat it as constant, because you hold y constant. So it is e to the x cos y. Alright? The partial derivative of u with respect to y. Well, in this case, you treat e to the x as if it's a constant. X is a constant, right? You treat x as a constant. When you differentiate cos, you get negative sign. So it's negative that sine y. Okay, good. Now, what about the partial derivative of v with respect to x and with respect to y? Well, the partial of v with respect to x is going to be what? V with respect to x here is going to be negative e to the x sine y, right? Because e to the a function of x, e to the negative x. You remember your chain rule. So it's negative e to the negative x sine y. There is negative e to the negative x sine y. Right? And then the partial of v with respect to y, delta v by delta y. Well, let's see what y was again. V was the sine y. When you differentiate sine, you get cos. So you're going to get e to negative x cos y in this case. So it's e to the negative x cos y. Alright, good. Now, take a moment to look at this. Here, this is del v by del x. You're supposed to find del x by del v. That's why it says inverse. Alright? And it's not a case where you can just put del x by del v. Alright, just put del x over del v here. So you put 1 over the other. It's not, no, that's not the case. Alright? Here, notice you have del u by del x. You're supposed to find del x by del u. Here you have del u by del y, but you're supposed to find del y by del u, right? And here you have del v by del y, but you're supposed to find del y by del v. So that's why you say it is inverse. So let's look at how this one is going to go. Suppose we consider this equation again, delta u. Now delta u, let's rewrite it. Delta u, or del u, I mean, the small change in u is equal to delta u by delta x times del x plus delta u by delta y times small change in y. Alright. What is delta u by delta x? Let's see. Oh, we have it here. Delta u by delta x is e to the negative x cos y. So let's erase this and put the e to the negative x cos y there. This is e to the negative x cos y. Alright, good. Now, oh, e to the x cos y. What are we talking about? It's not negative, it's positive. E to the x cos y. E to the positive x cos y that we have. Alright, good. Now, what is delta u by delta y again? This. See it here now? Delta u by delta y. So we're going to erase this and put what delta u by delta y is equal to. So let's erase that. We say this is delta u by delta y. But this is going to change to minus. So it's minus e to the x sine y. Alright, so what we have there is that the change in u, the small change in u, is equal to e to the x cos y del x minus e to the x sin y del y. Good. Now, what about del v? The small change in v is equal to the partial derivative of v with respect to x times a small change in x plus the partial derivative of v with respect to y. Oh, let me rewrite that part up top again. The partial derivative of v with respect to y times a small change in y. But what is partial v by del v by del x again? Delta v by delta x, I mean, is this. So what we get here then is minus e to the negative x sin y. You see that? See. Then here. Oh, why did I write a plus? Minus here is a plus. See here now. My mistake. Plus delta v by delta y del y. What is delta v by delta y? Here it is, which is this. Alright, so let's erase here and put e to the negative x cos y. So that's what we have. Right? So here now, delta, we have, in this case, we have two equations here. Well, these is really a pair of simultaneous equations when you think about it, you know. Alright? Let us call this, let's call this equation 1 and this equation 2. Interesting. Now, what can we solve to find? Well, remember, in our usual simultaneous equations, what we could do is switch this around. Let's rewrite these and see what happens. This is e to the x cos y times delta x, but the delta x, let's give delta x its own color, delta x minus e to the x sin y times, let's say we have delta y here is equal to small change in u. That's equation 1. Alright, good. This one now. Let's say this is negative e to the negative x sin y times delta x minus, plus, it would be plus e to the negative x cos y times delta y is equal to change in v. Alright, this is equation 2. Now, you can see that we have delta x twice here, delta y twice here. It's similar to, say, you have 3x plus 4y equals 7 and 5x minus or plus 8y equals 15, something like that. Alright? And you eliminate x to get y, eliminate y to get x. So let's eliminate delta x and see what we would get. How do we eliminate delta x to get delta y? Well, what we could do is equation 1 by e to the by negative e, or let's get equation 1 by e to negative x sine y. Alright? Now notice if you multiply equation 1 by e to the negative x sine y and then equation 2 by e to the x cos y, we will get the same thing times delta x above and below, and we could just subtract them or add them in this case. So equation 1 by e to negative x sine y. What happened when you do that? Well, here we have e to the x cos y times e to the x sine y. Well, it would be here e to the x sine y times this and multiply by delta x, right, minus, alright, just to double check, that's what we have so far. Everything okay with it? Just double checking something here. We have one equation. Change in u is e to the x cos y delta x minus e to the x sine y delta y. Good. Equation 2, change in v is negative e to the negative x sine y. Well, I said delta x. This is del x. Del x plus e to the negative x cos y del y. Alright. Remembering that we have two types of delta. One we call delta, the other one we call del. Alright, so we're multiplying. So e to the x cos y multiplied by e to the negative x sine y. Oh, I didn't put the negative here. Alright. Minus. Up top here is e to the x sine y. I will multiply it by e to the negative x sine y. And then we have our delta y. Alright, good. Is equal to, and then e to the negative x sine y will multiply our del u. Okay, so that's what we have there. All right. Now, the next thing, equation 2. We want equation 2 to be multiplied by e to the x cos y. Alright? So, this will multiply this, this, and this. Okay? So here we have e to the x cos y times, well, it will be negative. Let me put the negative sign out here. E to the negative x sine y times del x plus, this will be e to the x cos y times e to the negative x cos y. No, it's equation 2, right? Equation 2 I'm multiplying by. So this is e to the x cos y, e to the x cos y, multiplied by e to the negative x cos y, e to the negative x cos y. Good. And then times the delta y. Good. Equals. And we have e to the x cos y will multiply del v. So it's e to the x cos y multiply del v. Alright, so that's what we have there. Now, suppose we add, right, in order to eliminate delta x. What would that? See, this e to the x cos y, e to the negative x sin y, plus negative e to the x cos y, e to the negative x sin y. See, this and this are the same, you know? Right? This part and this part are the same thing except for the negative sign. So you have to add to eliminate. So this is gone. This part is out. Alright? Now we have negative e to the x sin y, negative e to the x. Let me not bother write it all the way out here. We have negative e to the x sin y, e to the negative x sin y by delta y, right, plus e to the x cos y, e to the negative x cos y delta y is equal to and then this is e to the negative x sin y del u plus e to the x cos y del v. Alright, we have that. Now, let's see how this part will go. Alright, so here now, let's rearrange this. Let's put this part first. I'm going to put this part out here first. This is e to the x by e to the negative x. See them here? Then cos y, this one, and then this one, cos y by delta y. Alright, minus this and this. We have e to the x, e to the negative x, then sin y, see that? Sin y, and then we have our del y is equal to, now here, this is going to be e to the negative x sin y del u plus e to the x cos y del v. So now, notice here, what we have is that e to the x times e to the negative x, that's 1. Cos y is cos squared y. And this is del y, small change in y, minus e to the x by e to the negative x is 1. Sine y is sine squared y. Right? We have del y. And that is equal to, now we have our e to negative x sine y del u, small change in u, plus e to the x cos y, small change in v. So we have this here. Here now, we factorize. We get our del y times cos squared y minus sine squared y is equal to, so we have our e to negative x sine y times a small change in u, right, plus e to the x cos y times a small change in v. So now our delta y is equal to what now? Oh, by the way, trig identity, cos squared y plus sine minus sine squared y is the same as cos 2y. So let's just rewrite this, and cos 2y is equal to e to negative x sine y delta u plus e to the x cos y delta v. We divide both sides by cos 2y. This will be divided by cos 2y. This will be divided by cos 2y. Cos 2y cancels cos 2y here. So what we have is that delta y is equal to e to the negative x sine y over cos 2y del u plus e to the x cos y over cos 2y del v. So that's what we have there. All right. Now we consider that the general form small change in y is equal to the partial derivative delta y by delta u times a small change in u plus delta y by delta v times a small change in, oh no, let me rewrite that part, delta y by delta v times a small change in v. Alright. Now when we compare these, we have this. We have this coincide. We have these coincide and we have these coincide. You see that? So what it means then is that delta y by delta u is equal to e to the negative x sine y over cos 2y. And we see here that delta y by delta v is equal to e to the x cos y over cos 2y. Right? So you notice that delta y by delta u is e to the negative x sine y over cos 2y, and delta y by delta v is e to the x cos y over cos 2y. Now what we have here is a delta y by delta u, right? Here we're saying that we want delta y by delta u. Earlier you found, what was it that you found again? delta u by delta y. This was delta u by delta y. It was negative e to the x sine y. But now we found delta y by delta u. And delta y by delta u is not 1 over e to the negative x. What was it? Is not 1 over e to the x cos y, right? It's not 1 over e to the negative x sine y. It's this, right? Now here you see that delta u by delta y was minus e to the x sine y. So as we saw earlier, delta u by delta y was e to the x sine y. Negative e to the x sine y. Is that that? Negative e to the x sine y. Right? But what we have here is something else. Alright? And here, delta y by delta u is e to negative x sine y over cos 2y. Now, delta u, what was delta u by delta y? Again, we found earlier. Delta u by delta y wasn't it? Let me see something. Delta y by delta v. Oh, this is v. I didn't write it properly. I was calling this u. This is v. Let me erase and rewrite this. This is delta v. And this is delta u. Alright, so delta y by delta u, right? This is delta u by delta y. From earlier, what was delta v by delta y again? Delta v by delta y was e to the minus x cos y. It was e to the minus x cos y. That was delta v by delta y, right? Different is not 1 over e to the negative x cos y. This is what you get. Alright? So, we found out, we had found, what was it we found again? Del y. We're going to eliminate del y next time and do del x, but with the amount of time spent so far and the amount of work and the stress level, we'll break from it and do that in another video. So I'll see you then.